Good afternoon. My name is Yongseok from Mellanox, and I'm going to talk about how DPDK embraces the externally allocated memory. And I made sure that there's no automatic transition of the slide today. So what is externally allocated memory? That is literally, it's allocated and managed outside of the DPDK. And for example, the storage buffer, storage application like SPDK or the GPU type of application, those inherently use the huge pages of, not using the huge pages of DPDK for zero copy purposes. And a lot of guys are familiar with the VPP, and VPP has its own memory management system, not using DPDK's memory management. So Case one, it's something like what VPP has been doing. So it has own, private memory management because according to the VPP, guys, DPDK is not the only way to support the framework. So they do have their own memory management system. They still want to use their own memory management. So in that case, they're using they're using this API, this one, the LT mempool populate IOVA. Yeah, that can be used for mempool, only for mempool, not for other data structure. So but still, the memory has to be registered for DMA using this API, LT VFIO DMA map. I will get back to this point, this API later in this slide. Anyway, this is kind of current use case of the externally allocated memory, but maybe deprecated pretty soon. Because Anatoly from Intel, he submitted a new way of handling externally allocated memory, and then it's been merged since in this release 1811, and also he made some good documentation in the programmer's guide, so you guys can refer to that. Let's do the deep dive. So this is actually I got it from Anatoly's presentation in Dublin Summit few months back. There were so many complaints about DPDK memory because DPDK is so greedy. Actually, Bruce made that kind of presentation last year, and DPDK was greedy, and then DPDK tried to monopolize all the use pages available in the system. But Anatoly changed that situation in 1805. So since 1805, we changed the way to the manage and the memory on the system. So this is the legacy DPDK memory architecture, which is so greedy. And then on the initialization, DPDK usually try to acquire all the available use pages on the system, and then I don't know why, but we try to make the VA, the virtual address layout and the physical address layout, the same, but which is not necessarily needed. Anyway, the VA and PA layout is fixed and it's not changed. So once the huge pages got acquired from the system, it is fixed there, and the VA space and the PA space are all aligned. So not much flexibility. But after that, 1805 had this patch. So now the VA layout is independent from PA layout, and it is quite on-demand basis. So it doesn't require that many huge pages on the system, but it allocates the page by page from the system if it is needed. So like you see in this diagram, the physical pages are all like of course, contiguous, right? But the pages managed by managed by DPDK, no, it's not contiguous anymore. So but on the initializing stage, the EAL init stage, if I remember correctly, the memory management system is trying to reserve the very huge virtual address space, like this orange bar. So whenever it's needed, it acquires a page from the system and it maps to this pre-reserved virtual address space. So it is so dynamic right now. So not greedy anymore. And based on that, I think you have to remember this structure, at least, the LTE memsec. So one memsec represents a page, in a DPDK. So the one page is managed by this one, LTE memsec struct. So, and then, per each socket and per each page size, there's a unique memsec list to have, all the mem segments, on that specific socket and the page size. So based on that memsec list, DPDK will, create will add the memory to the malloc heap, and then based on that malloc heap, as you know, you can reserve a mem zone, or you can create a mempool based on that, or you can use LTE malloc like that. That was the huge change, and then it's pretty good for everybody. So now the problem is that how can we enable people to use their own memory allocation? So what Anatoly made, what Anatoly submitted is something like this side. So I draw this, I try to make it, look same. So it looks like it's good. And so here's the thing. There are a bunch of these blue squares. There are a bunch of externally allocated memories. Of course, the page by page. And then, we want this to be, the same as the memories, managed by DPDK, meaning, we want to use this kind of external allocated memory for the LTE malloc and mempool and memzone, everything. So we want you to have the same structure like this bottom, right? So Anatoly, had a great idea about this. So this change, is using, the main idea of this change is using a kind of invalid socket ID for the external memory. So like this, as you can see this in this macro, external heap mean socket ID is, the larger than the max number of nodes on a system, right? Defined. So for example, kind of 256, I guess. So that is assigned to, kind of the externally allocated memories, the region, So the socket ID, the invalid socket ID is used for that externally allocated memory. And how do you, that means, that enabled people to use these kind of, the existing APIs to allocate memory. So we do have, all the, memory allocation APIs, we have, all the standard memory allocation APIs. Those have the socket ID as an argument. Then you can use that that invalid socket ID to specify, to ask, this API to get the memory from that externally allocated memory. So when it is added to the system, then like you saw in the diagram, it dynamically creates a new memsec list for that range of memory, externally allocated. And then there's a new field here, like in the MSL structure, memory segment list. There's an external bit field to mark it as, it is an externally allocated memory, right? And it keeps track of IOVA addresses, and and this is the quite important topic. It actually generates the memory allocation events, the alloc and free events, so that the memory registered by the API can be registered for the DMA, kind of VFIO, or in case of Mellanox, we do have different memory registration. We don't use VFIO, but it is standardized like this. So this registration will generate the allocation and free event. Then the PMDs and other components in the DPDK can know that there's a new memory registered externally, allocated externally. So the VFIO will call that VFIO mem event callback to register the memory, and even the Mellanox PMD will hook up the event to register the memory to the device. It is pretty cool. How to use? Very simple. Yeah, I like this design, Anatoly's design. So first, you need to create a named heap. So call this API, alt-malloc heap create with name. And then, if it is successful, you can register your external memory to the heap by calling this API. The second one, but you should give the address and its virtual address, and its IOVA means the physical address, right? And of course, length and number of pages and page sizes. It's the granularity here is the one page size basis, right? So the next, you can get the socket ID by using this API, and then since then, you can use any of the standard DPDK allocation APIs with that socket ID. Then the returned memory will be coming from the external memory you registered. So it's pretty cool. Example code, you can find two example codes. It is under the test, the unit test, and then the test PMD has a new argument, specifying xmem hues, which is which represents the external memory. And then inside the test PMD code, you can find setup extmem function, and you can refer to that. That's straightforward. K3. That's a little bit different topic. In some cases, like storage or GPU, people don't like to put any overhead on their externally allocated memory. I mean, if it is added like I presented so far, then it has to have the overhead for the malloc heap. So it has to have the extra data structure, for the malloc heap. But sometimes, the storage or GPU type of application, they don't want that kind of overhead, and they just want to use their externally allocated pages as is, not having the overhead by for the malloc element, because they don't want to use any malloc API for that external memory. So in that case, like I mentioned briefly, you still need to register the memory for the DMA, but that doesn't mean that it is managed by DPDK. So it doesn't create any memsec list or memsec structure for that for that externally allocated memory. So I will get back to the point later. But here I want to introduce a new way of sending packets, with this kind of external big chunk of buffer. So if you have if you have a big chunk of memory, this kind of external memory, and then you want to slice it and send it over the network, the packet by packet, what are you going to do? I think, in the morning, the SPDK people introduced, briefly mentioned about this, and then what you're going to do is, before 1805, you had to do some kind of mbuf indirection, or you had to do some kind of hacks to fake the buffer address inside an mbuf. So mbuf indirection is actually, for the buffer cloning, but I introduced a new way of doing that, like this externally attached mbuf. So now, since 1805, externally attached mbuf is possible. I had to introduce this feature for our, the multi-packet receive feature. So things here is, you can attach, unlike this direct versus indirect to mbufs, which has to be, coming from the mempool. But now you just can attach an external buffer, which is not necessarily be an mbuf. So it can be any type of buffer. Could be, it is could be a storage buffer or the GPU buffer. So, but if you use this standard API, the RT packet mbuf attach ext buff, then you can attach an external buffer to the mbuf, and it will replace the buffer address and everything, and it is, so compatible with the existing mbuf APIs. But the difference is that there should be some shared info to keep track of the buffer, external buffer. I mean, reference counter and the free callback for the buffer. So there's a new field here. mbuf has a shared info to store that reference counter and then free callback and its argument. So the example is like this. This is the storage buffer, and then if you want to slice it and send it, over the network one by one, you need to put a network header ahead, right? It's simple because we support the mbuf chaining, so you just can create one mbuf for the networking header like this, and then you need to create one more mbuf to reference to that data on the external buffer, and then you just need to, make a chain using that, the APIs in RT mbuf. So now, like I said, I have to mention about this API because currently this is the way how you can register DMA memory for the external buffer, but not every device uses VFIO. That's the problem. And then Anatoly and Mellanox, we agreed that this should be replaced with a more generic API like RT dev DMA map kind of thing. It is generic and vendor agnostic API to register the external memory for the DMA. Still ongoing discussion, this RFC stage, so you're welcome to join the discussion. So okay, so in case of Mellanox, we don't use IOVA, the physical address on our descriptors. We use virtual addresses because the device has some kind of IOTLB entries, which has to be pre-registered on the initialization. So that's why we don't use the VFIO, but we thought that was, for the better security between VMs and hypervisor. So anyway, we do have different ways to register the memory for the device. So that's why we think that there should be a standard, more generic API to register the memory. So and this is quite new. Anatoly sent out a patch last maybe Thursday or Friday. So, and during the discussion, we thought that the VFIO DMA map has a bug, and it doesn't create like I said, it doesn't create a memsec list, so it is not managed by DPDK, even though it is registered by the API. So we thought that we needed a way to create a memsec list for external memory without having that malloc heap overhead. So there's a new API suggested by Anatoly like this, the LTE-EXT mem register. So it is basically register your external memory, and it creates the memsec and memsec list, but it doesn't generate that memory event, allocation and free, because he wanted people to have two separate codes for this in this case. So one is the registering the external memory, and the other one is the like this the new API we are proposing, the dev DMA map, which is which will eventually call VFIO map in case of Intel NIC or others, and which will take care of, in case of Mellanox NIC, the Mellanox PMD will take care of the registration. So this is the current status, and then it's still under review. So everybody can review the patch. And I mean, in my slide, I put the link, so you can click it and you can go, you can see the patch and then everything. So pretty much it. Questions? Yeah, I try to be very, very informative, and then, yeah, I saw that a few folks presented this morning or yesterday was complaining about the DPDK is greedy and kind of memory allocation is quite difficult. I mean, not easy to use, the external memory, and then in the morning, SPDK. I thought that SPDK guys were using that external buffer attachment, so I was glad to see that. But anyway, if you have any questions, or later.